Good day, everyone. Today, let's have the continuation of the discussion of the derivatives of transcendental functions. So this time, we will be applying the different differentiation rules, the sum rule, the difference rule, the product rule, and the quotient rule in deriving transcendental functions. Let's start. Suppose we have the given function f of x is equals to 4 cosine x plus 2 sine 3x. So in this case, we are going to apply our knowledge that we have discussed or that we have learned during the discussion of the transcendental functions. And we will apply the concept of the different differentiation rules. So f prime of x is equals to, our first term is 4 cosine x. Then if we are going to derive 4 cosine x, so copy the coefficient 4, then the derivative of cosine x is sine x, or negative sine x rather, times the derivative of the expression x, which is equals to 1. Plus, let's have the derivative, the second term, so 2 sine 3x, that is 2. The derivative of sine 3x is cosine 3x, times the derivative of the algebraic expression, which is 3. Then we will do further simplification. So f prime of x is equals to 4 times negative sine x times 1, that is negative 4 sine x. Then for the second term, we have 2 times cosine 3x times 3, that is plus 6 cosine 3x. Let's have the second example. Our function is 7 tangent 5x minus 8 cosecant 9x. So we will do the same. We will derive the functions term by term. Starting with the first function or the first term, we have 7 tangent 5x. So copy the coefficient 7. Then the derivative of tangent 5x, that is secant squared 5x, times the derivative of the algebraic expression 5x, and that is 5. Minus, we will do the same for the second term. So copy the coefficient 8. Then the derivative of cosecant 9x, that is negative cosecant 9x cotangent 9x. Then we will multiply it to the derivative of our given algebraic expression, which is 9x, and its derivative is 9. So we have f prime of x is equals to multiplying the factor 7 secant squared 5x and 5, you'll get 35 secant squared 5x. Then multiplying 8 negative cosecant 9x cotangent 9x and 9, you'll get positive 72 cosecant 9x cotangent 9x. So the derivative is f prime of x is equals to 35 secant squared 5x plus 72 cosecant 9x cotangent 9x. Let's have another example. F of x is equals to negative 13 e to the power of negative 4x plus 2 secant x squared. So f prime of x is equals to the first term. It is under the exponential function. So we are going to copy the coefficient, that's negative 13, times e to the power of negative 4x. Then we will multiply it to the derivative of the given algebraic expression, which is negative 4x. Then its derivative is negative 4. Plus, for the second term, we have 2 secant x squared. So copy the coefficient 2. Then the derivative of secant x squared, that is secant x squared tangent x squared. Then the given algebraic expression is x squared. If we will derive x squared, that becomes 2x. Next, we will simplify. So f prime of x is equals to multiplying negative 13 e to the power of negative 4x and negative 4. The result is 52 e to the power of negative 4x. Then multiplying 2 secant x squared tangent x squared and 2x. The result is plus 4x secant x squared tangent x squared. Next, let's have f of x is equals to negative 2 cotangent 4x squared minus the logarithm of 7x to the base of 9. So f prime of x is equals to the derivative of the first term. So copy the coefficient negative 2. Then the derivative of cotangent is negative cosecant squared 4x squared times the derivative of the given algebraic expression 4x squared, that is 8x. then minus the derivative of the logarithm of 7x to the base of 9, that is 1 over 7x ln 9, times the derivative of the algebraic expression 7x, that is 7. So further simplifications, we have f prime of x is equals to multiplying negative 2, negative cosecant squared 4x squared, and 8x. The result is 16x cosecant squared 4x squared. And then next is for the second term, we can cancel out 7. So what is left for the second term is minus 1 over x ln 9. So that is by the use of the addition rule or the sum rule and the difference rule of the differentiation formulas. This time, let's have the product rule. So suppose our given function is f of x equals x squared sine 4x. So in using product rule, again, we have to remember that we have to identify h of x, which is the first factor of the given function, g of x, the second factor of the given function, and of course the derivatives or or their corresponding derivatives, h prime of x and g prime of x. So h prime of x is the first factor, and that is x squared. Its derivative is 2x. Then our second factor of the given is g of x, and that is sine 4x. Then its derivative is 4 cosine 4x. Now, using product rule, we have the formula f prime of x is equals to h of x times g prime of x plus g of x times h prime of x. Substituting it to the formula, so we have f prime of x equals our h of x, x squared, times our g prime of x, that is 4 cosine 4x, plus our g of x, we have sine 4x, times h prime of x, and that is 2x. So multiplying x squared and 4 for the first term, so the result is 4x squared, then copy cosine 4x. For the second term, we are going to multiply 2x and the coefficient of sine 4x, which is the imaginary one. So therefore, the second term is plus 2x sine 4x. Let's have the second example under product rule. F of x is equals to 4x cubed tangent 2x. So again, we will identify h of x, g of x, and its corresponding derivatives. So h of x is the first term or the first factor of the given function, and that is 4x cubed. Its derivative is 12x squared. Next, for g of x, the second factor of the given function, and that is tangent 2x. Its derivative is 2 secant squared 2x. So applying the formula of the product rules, we have f prime of x is equals to our h of x, which is 4x cubed, times g prime of x, that is 2 secant squared 2x, plus our g of x, that is tangent 2x, times our h prime of x, that is 12x squared. Now, we will multiply 4x cubed, 2 secant squared 2x. The result is 8x cubed secant squared 2x. Remember, you are going to multiply 4x cubed to the coefficient of secant squared 2x, which is 2. So that's why it becomes 8x cubed, then copy secant squared 2x. We will do the same for the second term. So 12x squared, we are going to multiply it to the coefficient of the tangent 2x, and that is the imaginary one. So that will give us the result of 12x squared tangent 2x as the correct derivative. Now this time, let's have the use of quotient rule. So for quotient rule, same process with the product rule, you have to identify the h of x, the g of x, and their corresponding derivatives. So in the given function, 2 sine 4x over x squared, h of x is the numerator, and that is 2 sine 4x. Then its derivative is 8 cosine 4x. Then for the denominator, that is our g of x, and that is x squared, then its derivative is 2x. So using the formula in quotient rule, we have f prime of x is equals to g of x times h prime of x minus h of x times g prime of x will over g of x quantity squared. So we will do the substitution process or method. So we have f prime of x is equals to our g of x, that is x squared, times h prime of x, we have 8 cosine 4x. Then minus our h of x, we have 2 sine 4x times our g prime of x, and that is 2x. All over, our g of x is x squared, then quantity squared. Now, f prime of x is equals to multiplying the first term in the numerator. We have x squared times 8 cosine 4x. The result is 8x squared cosine 4x. So all you have to do is to multiply x squared and 8. That becomes 8x squared, then copy cosine 4x. Then for the second term, we have minus. This time, we will multiply 2, the coefficient of sine 4x, and 2x. So the result is 4x sine 4x. All over, if we are going to square x squared, that becomes x to the fourth. Now, as you can see, in the numerator, the first term is 8x squared, and the second term has 4x. If we are going to examine the two, we can say that there is a common factor between them, and that is x. So by that, we can factor out the common factor, which is x. So 8x squared will become 8x, and 4x will become 4. So that is why it becomes x times the quantity of 8x cosine 4x minus 4 sine 4x. Then all over x to the fourth. Then by that, we can cancel out x in the numerator and one variable x in the denominator. So we have f prime of x is equals to, what is left in the numerator is 8x cosine 4x minus 4 sine 4x all over x to the fourth becomes x cubed. Kaya nag-cancel tawag isa ka variable x. So the correct derivative is 8x cosine 4x minus 4 sine 4x all over x cubed. So that's it for today's presentation. Now this time, let's test yourself. You are going to derive the following functions. You may pause the video and start answering the 3 given examples. Then you may play the video again to check if your answers are correct. So these are the answers of the following functions. Okay, so a round of applause for everyone for getting it right. Now see you on Friday for the summative test.